Hi guys, today we're going to talk about surface area and volume of cylinders and cones. So we've been talking about prisms and pyramids, obviously, and prisms and pyramids have polygonal bases, a prism with two bases, and pyramid with one base. But what's the difference then between a cylinder and a cone, or cylinders and cones, when you compare those to prisms and pyramids? Obviously, the critical difference there is that the base or bases are circles instead of polygons, right? So a cylinder is a prism that has two congruent bases, always circles, like a can of soup, a soda can, whichever you prefer. You can have a right cylinder, an oblique cylinder. Remember, an oblique cylinder, then the height is still perpendicular to the plane containing the bases, but if you were just to join the centers of the bases, then that would not be a height. So the lateral area of a cylinder is the area of the curved surface of the cylinder. Okay, so imagine for lateral area that you took something like a paper towel roll or a toilet paper roll and cut it vertically along the curved surface and then unroll it, and the area is a rectangle. So how do we find the lateral area of a cylinder? Well, let's think about the fact that a cylinder, and you're talking about the lateral area, and in this case, so we might be considering shading along all of this surface for something like the lateral area all the way around, like the tube of a toilet. So you might want to say, well, how much cardboard do I need to create a paper towel roll or to create a toilet paper roll or something like that? And that's what we'd be talking about. We'd be talking about the lateral area. And what else could lateral area be good for? Printing labels on soup cans, obviously, or any kind of vegetable cans or anything like that. You would be concerned about the lateral area. So where does that come from? Well, how do you measure the distance around a circle or around the cylinder? That would be circumference, right? So circumference, what's the formula for circumference? That would be 2 pi r, or pi d, I know, but we're going to use 2 pi r in this case. And then we're going to measure by how tall that cylinder is. So that would be the height. Okay, so the lateral area comes from 2 pi rh. Remember that r represents the radius of the circle, the circular base, and h is the height of the cylinder. And that'd be helpful if I spelled cylinder correctly. Okay, sometimes just to give students a mnemonic device to try to remember, I'll just try to say, okay, 2 pi's are hot. Maybe that's a good mnemonic device, hopefully, to remember the lateral area of a cylinder. So total surface area of a cylinder is going to be the lateral area plus the area of the two bases. So that's the sum, and it just says that right here, so I don't need to write that. So total surface area is the sum of the lateral area and the area of the bases. So if you wanted to consider, well, how much tin do I need to create that can that's going to hold the soda or hold the soup, that would be concerned. You'd be concerned about the total surface area. So again, your total surface area is going to be the lateral area plus your total surface area is going to be lateral area, just like for prisms, lateral area plus 2 times the area of the base. In this case, we're going to write it as 2 pi rh, which was the lateral area, plus 2 pi r squared. Why? Because remember, this is the area of a circle, is pi r squared, and we have 2 circle bases, right? Okay, so and if you prefer to write it in a different way, remember that you could potentially factor out the greatest common factor between these two terms. That would be 2 pi r times h plus r. That's just another way of writing the exact same thing, right? And still keep in mind that, again, radius r is equal to the length of the radius of your circular base, and h is height of your cylinder, in case you forget what those variables stand for, right? And the base is the top or the bottom of your cylinder. And we say top or bottom, I do think that's confusing for some people. The base doesn't have to be the top or the bottom, but remember, for a cylinder, the base always has to be the circular parts, the two congruent parallel circles. Okay, if you want to find the volume of a cylinder, think about filling up that can, right? So we're going to say the area, the volume of a circle is the amount of space to fill a cylinder, right? And it's measured in cubic units, and volume is the area of the base, which is pi r squared, right? That's the area of the circular base, times the height of the cylinder. So imagine, the way that I like to imagine that sometimes is like, imagine stacking quarters, and you know the area of one quarter, and then you stack another one on top and another one on top and another one on top, and it's solid, so that you make a whole roll of quarters, right? Okay, and you would figure out that volume by finding the area of one and multiplying by how tall your cylinder is, or how tall your roll of quarters are. Okay, so let's move on and see about applying some of these a little bit. So the radius of the base of a cylinder is 4 inches and its height is 6 inches. We want to find the surface area in terms of pi, right? This means not approximately. We're not going to approximate that at all. And if it would help you to draw a cylinder, certainly it's a good idea to draw an oval and another oval up high, and then connect them like with two vertical lines. If you want to try to make it look like it's three-dimensional, remember we use dashed pieces to make it look like it's three-dimensional a little bit. So you could try to make it look like it's three-dimensional, and then you may want to incorporate the length of the radius as 4 inches, and then the height of the cylinder as 6 inches. And we want to find the surface area. So if we're going to find the surface area, remember that that's going to be 2 pi r h, which is the lateral area, plus 2 pi r squared. Remember, we have two circular bases. So this really isn't different from a prism. It's just that the only difference is the fact that your base shape is a circle, right? Okay, so 2 pi times 4 times 6 plus 2 pi times 4 squared. And then we get 48 pi plus, that's going to be 16 times 2, which is 32, right? And so our total surface area is 80 pi inches squared. This was area, so it's, again, remember it's measured in square units. Got it? And so we don't even need to type that into our calculator, because you're going to leave your answer in terms of pi. All right, next one. We have the drums of a roller are cylinders of length 3.5 feet, and the diameter of the large drum is 4.2 feet. What area does the large drum cover in one full turn? So you kind of have a visual aid right here, just to try to get you to understand what we're talking about. Imagine almost like a paver on the street that would be rolling out the tar or pushing it down to smooth it out a little bit. So we're kind of concerned about what's the drum that we're talking about. Well, that's this piece right back here. This is the drum that we're talking about, okay? And it's over here on this roller. I do not know the proper term, and I should. So imagine that that's a cylinder right there, and we're just going to take it out and bring it over here a little bit so that we can deal with this, okay? And then we're going to make sure we know what we need to do. We definitely do want to approximate, so we will type it in after we've gotten all the way through, okay? And we have a cylinder of length 3.5 feet, and the diameter is 4.2 feet. And so we want to know, what is the area the large drum covers? Well, then what are we really talking about here? Are we talking about surface area? Are we talking about lateral area? Or are we talking about volume? So if we're just going to roll this drum around, right, we're rolling this drum around here, we're not covering the ends at all, so we don't really need to know anything about those circular bases. The radius is what helps us. However, we're not covering those pieces because that part is not rolling along the ground. Okay, so we need to know, what is the lateral area? That's what we're looking for. That's the unknown thing. So remember, our formula for lateral area is 2 pi RH. All right, so let's see what we need to plug in for that. We have the diameter of the drum is 4.2 feet. So I know sometimes some of you are uncomfortable a little bit when things are lying on their side, but remember, where the diameter is the diameter of the circle. So this is the piece that's 4.2 feet. And so how much is the radius there? That's 2.1 feet, right? And then the length, that's from end to end of that cylinder, that's 3.5 feet. So there we go. So now we should have everything that we need. That would be the height of the cylinder, and that would be the radius, right? So we should have everything that we need to plug in. 2 pi times 2.1 is the radius, and 3.5 is the length of the cylinder or the height of the cylinder. And at this point, you should probably just type everything in. 2.1 times 3.5 times 2 pi. And you can say that the area that it covers, and we're going to round to the nearest square foot, that's going to be whole number, right? This should be a whole number. It doesn't say the nearest tenth of a foot or hundredth of a foot. So this lateral area that it's going to cover is approximately 46 square feet. And in word problems in general, you want to phrase your answer in a nice sentence. So the drum covers an area of approximately 46 square feet. And why would you be concerned about that? Well, if you're laying out tar, you would definitely be concerned about, how much you need. Or if you're going to be concerned about how long, the time it takes, you might know about how long it takes for it to make one revolution and how much you have to do. So you might get an idea, an estimate about how long it might take you to be able to do a job, okay? All right, in this next one, we're going to find the volume of the cylinder. It looks like we pretty much have everything we need. Volume for a cylinder, remember, is going to be the area of the base shape, which is pi r squared, times the height of the cylinder. So we already have the radius, that's 3 squared, times the height, 8. And so that's going to be 3 squared is 9, and 9 times 8 is 72. Pi centimeters cubed. Remember, we were finding volume. It didn't say anything about approximating your answer. I'm just going to leave it like that for now. Okay. Next, let's talk about cones. So a cone is similar to a pyramid, similar to a cylinder, but the base is a circle. In a right cone, the altitude is the perpendicular segment from the vertex to the center of the base. Remember that very often we're going to use that term altitude synonymously with height. I'll use those terms interchangeably a little bit, but remember that height is really just the length of the altitude. And the slant height, that's a new one, and we've talked about that with respect to pyramids. The slant height is the distance from the vertex to a point on the edge of the circle. So that's tracing a path along. When you're finding the slant height, then you are actually tracing a path along the lateral surface of your cone, okay? So the slant height is when you trace a path like this from the vertex along the lateral surface of the cone, the curved surface, down to a point on the circular base, and that would be the slant height. Got it? Remember that the height always has to be from the vertex perpendicular to the line containing perpendicular to the surface, to the plane that contains the circular base, not necessarily straight up and down to the center. Sometimes it is, sometimes it's not. In an oblique cone, that would not be the case. So lateral area of a cone is going to be the area of the curved surface of a cone. Right? And the formula for lateral area of a cone is this. It's pi r L. And it seems strange. It doesn't seem like it's related to anything else. It's similar, actually, to the lateral area of a pyramid. I don't know if you remember, for a pyramid, the lateral area was 1/2 perimeter of the base times the slant height, right? Okay, so let's talk about how that might be related. Well, we don't talk about, for a circular base, we don't talk about perimeter, we talk about for circumference. So for a cone, we would say 1/2, and then circumference is 2 pi r times the slant height. And then what happens with the 1/2 and the 2, they cancel out. And so the resulting formula is just pi r L. Remember that r, again, is equal to the length of that radius, and L represents the slant height. Okay? All right. So surface area of a cone would be the sum of the lateral area and the circular base. And circular base area. Okay, so surface area of a cone is obviously going to be lateral area plus the area of one single base, very much like a pyramid. But in this case, we're going to go ahead and say pi r L plus, and remember that for a cone, the shape of the base is a circle, so that would be the area of a circle is pi r squared. Got it? Okay. And volume of a cone is given, remember, is like, is filling the space of a cone, right? And the formula for volume of a cone is 1/3 pi r squared h. Again, very much like a pyramid, and it comes from Cavalari's principle in slicing sections and fitting them into a particular space. And it has to do with the fact that that volume of a cone, assuming that you had an equal height and radius, then the volume of a cone would take up 1/3 of the volume of a cylinder. And so that's why it's 1/3 pi r squared h. And again, we're not really going to talk in depth about Cavalari's principle, but it is worth looking up and learning about Cavalari's principle. If we have time, we'll talk about it later. So let's see if we can apply some of this information, some of these formulas to find what we need to find. All right, so in example 4, we want to find the total surface area of this cone. So let's think about what we need. And in order to find the surface area, we're going to need the lateral area, which is pi r L, plus we need the area of the circular base, which is pi r squared, right? Okay, so it looks like we definitely have the radius, that's 15 centimeters, and we do have the slant height, 25 centimeters. So we should be good to go. We really don't have to do anything besides plug in what we know. Pi times 15 times 25 plus pi times 15 squared. Got it? So 25 times 15, excuse me, is 375 pi plus 225 pi, which will give you 600 pi centimeters squared. Just talking about surface area. And you weren't asked to approximate, so I'm just going to leave it as exact as possible. I'm probably only going to approximate when I'm asked to do so. Okay, so let's talk about maybe an application in chemistry. We have a funnel that's in the shape of a cone. How much filter paper do you need to line the funnel? So here we have, so let's think about what we need then. We're trying to kind of pour something maybe into a beaker through a filter. So we're going to take this filter paper out and think about what we need a little bit. Now you're not really told what it is you need to find, right? So how much filter paper do you need to line the funnel? So should we be looking for volume, or are we looking for surface area, or are we looking for lateral area? Well, if you just want the filter paper, then don't you want to be able to pour something through the filter paper, right? So we shouldn't have a top on the filter itself. We shouldn't want a closed surface at all. We should want it open, almost like a water cooler cup, like a Kentwood water cooler cup, if you will, or a cone of some sort that's open at the circular part, right? So that's how much filter paper we'd be looking for. Which means we're really just looking for what's the lateral area. That's what we're looking for. What is the lateral area? And that formula is pi r L. So let's think about whether or not we have everything. We've got pi. Do we know the radius? Sure we do. If the diameter is 8, we know that the radius is 4 centimeters, so that's easy. But we're not given the slant height. That's unknown. So we better figure out what that is. We do have the height, so obviously it looks like we could use that right triangle right there from the height, the radius, and the slant height so that we could figure out what the slant height is. So let's do L squared for the slant height is equal to 4 squared plus 7.5 squared, and you're really using that Pythagorean theorem a lot, so 16 plus And 7.5 squared is 56.25. If you add that, you get 72.25. And the square root of 72.25 is 8.5. Remember that we are taking the square root to find the slant height, so the slant height is 8.5. That is an exact value. That's not a rounded value. I'm not approximating that. Okay. And then, since now all we need to do, it says how much filter paper do you need? In this case, it probably makes sense to go ahead and approximate, right? It doesn't really make sense to talk about the amount of filter paper that you need in terms of pi. So let's go ahead and type that into our calculator and approximate that. And you need approximately, it doesn't say what value to approximate to, but we're going to go ahead and approximate to the nearest whole centimeter. So you need approximately 107 centimeters squared of filter paper in order to line that funnel. Got it? And that's it. Okay. All right, so now let's find the volume of an oblique cone. Volume we know we have a diameter and we have a height, and we want to give our answer in terms of pi, and then also rounded. So remember, this one is the exact value, and then rounded means your approximate value, right? We're going to give two forms. So some of us are really not sure, well, what does that oblique cone look like? So I'll draw you a little picture, kind of off on the side. It's not a perfect picture by any means, but hopefully it'll get done a little bit. And then remember that the height would have to be perpendicular to the plane that contains the base. So the height should come from the vertex and be perpendicular to the plane that contains that base. So I'm just going to draw an altitude there and say that's containing that. And we have a diameter of 30 feet. This is a very large cone, and a height of 25 feet. And we want to find the volume, and the formula for finding volume of a cone is 1/3 pi r squared h. And let's see what we already know. We must know that the radius is, if the diameter is 30 feet, then the radius has to be 15 feet, half the diameter. And we already know that the height is 25 feet. So we really are good to go. We've got everything we need. 1/3 pi times 15 squared times 25, right? So that's 1/3 pi times 225 times 25. I like to cancel. I try not to use my calculator as much as possible. 3 into 225 is 75, and 75 times 25 is 1875. So as an exact value, this is 1875 pi feet cubed, cubic feet, right? This is an exact value. And when you want to approximate it, just multiply that 1875 times pi. And the volume is approximately 5,890 cubic feet. Okay, let's see if we can clean that up a little bit. Approximately 5,890 cubic feet. Okay. All right, let's talk about a teepee. There's clearly a lot of applications for cones. So we have the covering on a teepee rests on poles, come together in concurrent lines. I don't know if you remember what concurrent lines are, but they intersect at a common point. In this case, that common point would be your vertex of your teepee, right? Okay. The resulting structure approximates a cone if it's 12 feet high with a base diameter of 14 feet. Estimate its volume. Well, I'm not sure really why we would care about that. Maybe we would be concerned about the amount of smoke that that teepee could hold, maybe something like that. So maybe then in that case we'd be concerned about the volume. Obviously we wouldn't fill it up with just all kinds of stuff. Okay, but let's see if we can estimate its volume. Remember that volume is 1/3 pi r squared h, and we have a base diameter of 14 feet, which means that the radius is going to be 7, right? So we have 1/3 pi times 7 squared. And we already know that it's 12 feet high. It doesn't say that that's the slant height. So I'm going to go ahead and maybe wrongfully go ahead and assume, but I'm going to assume that that's the actual height. And that's 12. And again, I'm trying to not use my calculator too much, so I like to go ahead and do that and cancel the 3 with the 12 to get 4. Now I've got pi times 49 times 4, and 49 times 4 should be 196 pi. And clearly we don't want to leave an answer like that, so we're going to go ahead and approximate that to the nearest foot, right? So we're going to say that the volume is approximately 616 cubic feet. The volume of the TP is approximately 616 cubic feet. That's how much maybe air or smoke or something else that it might hold. Okay. All right, last thing we're going to do is we're going to find the volume of a composite figure. And this composite figure is made up of 2 or more different solids. Okay, we're going to talk about it as 2 or more different solids in this case, just because that's what we've been talking about all along is solids. So let's think about what we've got here. And in this diagram, it looks to me, it's either looks like a backpack or a lunch pail or, you know, a kind of strange looking purse a little bit. All right, so it looks like we have a rectangular prism, and I would identify all of this piece as the rectangular prism, and maybe half of a cylinder. So it looks like we also have like half of a cylinder going on up at the top half over here. So let's talk about finding the volume, and that's going to be equivalent to the volume of a rectangular prism plus the volume of half a cylinder. All right, so remember, the easiest way for you to find the volume of a rectangular prism is actually just length times width times height. There's really no reason for you to make it more complicated than that. And then remember that the volume of a cylinder is pi r squared h, but we're only talking about half of a cylinder. Okay, so we're going to put a 1/2 in front of that. Now let's see if we can find all of the dimensions that we need to plug in. So it looks like we have a length of our rectangular prism of 12 and maybe a width of 4. We don't really know the height right here, so we're going to have to figure that out. We have a 17 overall, so we've got a 12 here, and we've got a 4, and we don't really know what that height is, so we're going to come back and find that out. Plus 1/2 pi, and we're not told the radius. Okay, so we also have something else that's unknown. We don't know what this radius is, right? That's an unknown, and we don't know what this height is. That's an unknown, right? Okay. And then the height of the cylinder is actually kind of from the front to the back here that you're looking at. So this would be the height of the cylinder right here. So that's actually already known. That's 4. So we actually also have that, okay? The height of the cylinder is different than the height of the prism. I'm going to think about those in a couple of different ways. So we're looking at what's unknown. Let's see if we can figure out how we get that. So let's take a look here. If I know that this is 12 and I want to split it in half, then this would be 6, right? And if I split this in half right here, because it's perfectly symmetric, it looks like, so this would also be 6. That would be the radius of your cylinder, right? So this is going to be 6 here. And then the height, well, if the overall height was 17, that's what was given from the very top of this container, compartment, whatever you want to call it, to the very bottom right here, the height, almost like you were trying to fit a suitcase in something, okay? If I take 17 and subtract that 6, then that means that this must be, the height has to be then 11, right? So I'm going to put 11 here, I'm going to put 6 here, and now we're ready to rock and roll. So this gives us 48 times 11 plus 1/2. I'm going to go ahead and cancel that 1/2 with the 4 just to make it a lot easier, right? That would be easier to do because then I end up with 36 times 2, which would give me 72 pi. And I like a little trick for multiplying by 11 where you split the digits and you get an 8 and you add them and you get 12, and that carries over to make the 4 into a 5. So 528 plus 72 pi, that would be an exact, right? That would be an exact volume. And this would be cubic inches. And if you want to approximate that, then you would say 528 plus 72 pi. And you can't add the 528 and the 72 first because there's no pi attached to the 528. So the approximate volume would be 754 cubic inches as an approximated. So we have both just in case you need whichever one. And that'll do it.